worksheet or somewhere on the side of your worksheet, you need to write down SOHCAHTOA. Okay, you need to write down SOHCAHTOA. There are a bunch of different ways to remember it. I've heard, let's see here, I learned, what did I learn? I learned, oh heck, another hour of algebra is what I learned, and just knowing that sine, cosine, and tangent are in order. There's some old horse caught another horse taking oats away. Some old hippie caught another hippie tripping on acid. There are a bunch of different ways. Some people just remember SOHCAHTOA. But let's go through what this actually stands for. So the S stands for sine. It's not sin, it's sine. Okay. O stands for opposite. H stands for hypotenuse. Hypotenuse. So your sine of an angle is equal to the opposite over the hypotenuse. Your cosine, and I'm just going to abbreviate that, COS, is the adjacent over the hypotenuse. I'm going to abbreviate hypotenuse HYP. Tangent, TAN, tangent is the opposite over the adjacent. Okay, so whatever it takes for you to remember that, you need to latch onto it. Now, here's where I think the other missing piece is identifying the correct sides. Identifying the correct sides. So let's do that. Let's look at number 1. So first thing I look for is I look for the angle. And when I get the angle, I'm going to draw a little curve right there in the corner of that angle, because this is going to help me label my sides. Okay, first of all, if the hypotenuse is involved, we need to identify that. Usually people are pretty good with identifying the hypotenuse, but if you need it, use the little right angle in the corner. Use the corner of that to point. That always points to the hypotenuse. So the hypotenuse is labeled as X, so I know that I'm going to use one of them that involves the hypotenuse. So tangent is out here. Tangent is out. Now, the reason why I drew this little curve is because the curve is always going to touch the hypotenuse, and the other side that it touches is the adjacent. Okay, if you are adjacent to something, you are right beside something, or you are touching something. So that side's always the adjacent, and then that leaves us with the opposite. So we know the opposite. We are looking for the hypotenuse. So which trig ratio uses opposite and hypotenuse? Sine. Okay, sine uses opposite and hypotenuse. So let's set it up. The sine of the angle, 51 degrees, is equal to the opposite over the hypotenuse. Now, two things we got to be sure of. Number one, we got to make sure we're in degree mode because our angle is in degrees. If you frequently reset your calculator, you will need to change it because it always resets back to radian mode. So make sure you're in degree mode first. Second thing, when the x is in the denominator, what ends up happening, I could show you all the steps, but what it boils down to is these two expressions switch places. The x and the sine of 51 switch places. You multiply by the x and then you turn around and divide by the sine of 51. So to solve for the side, the hypotenuse that they're wanting, it's 13 divided by the sine of 51 degrees. And that gives us 16.7. We'll just round to the nearest tenth. Is that what it says? Yeah, round to the nearest tenth. So 16.7 is our hypotenuse. Now, do a quick check. The hypotenuse is supposed to be, as far as its length, in relation to the other sides. The hypotenuse is always the longest. So one of our legs was 13. It's got to be longer than 13. We don't know how much longer, but it has to be longer, and it is. So at least do that quick check before you say that that's your final answer, or before you select the final answer. Okay, let's look at number 2. Okay, let's look at number 2. So draw your little curve at your angle. Figure out if you've got the hypotenuse. We do. This time we know the hypotenuse. And the x here is going to be the opposite because our little curve does not touch the side that has the x on it. So we're dealing with opposite and hypotenuse again, so it's still sine. The sine of 62 degrees is equal to the opposite. This time the opposite is the variable, and the hypotenuse is the number. So the sine of 62 is equal to x over 10. How do we solve that for x? X is being divided by 10, so we multiply both sides by 10. Okay? So the 10's cancel when we multiply, so 10 sine of 62, we multiply this time, 10 times the sine of 62, 8.8. Okay? Now this was one of our legs, so it should be shorter than the hypotenuse, and it is. So we're gonna go with that. Okay, let's look at number 3. Now it's a little crammed in there, but let's see here. 16, draw our little curve, point to the hypotenuse. So our hypotenuse is x. The 18 is the side that is touching that curve there, so that is the adjacent side. So adjacent and hypotenuse is cosine. Cosine of 16 is equal to the adjacent divided by the hypotenuse, so 18 divided by x. This is where we switch. So x is equal to 18 over the cosine of 16. So we get 18.7. The hypotenuse is supposed to be bigger than our sides. It is, not much. But look at that angle. I mean, it kind of makes sense looking at the picture that it's just a little bit bigger because that's such a narrow angle there. Okay, number 4. We got our 24 degrees, 15 is the hypotenuse. Draw that arrow in there. Our curve is touching the x, so the x is the adjacent, so we've got adjacent and hypotenuse again, so this is cosine of 24 is equal to the adjacent x over the hypotenuse 15. When you've got that constant in the denominator, you multiply both sides, because that's what's going to get rid of that dividing by 15. Yep. 15 cosine of 24 is 13.7. It's a leg, so it should be shorter than the hypotenuse, and it is. Okay, so what do y'all think 5 and 6 are going to be? Tangent. Let's see if it is. All right, 53 degrees. If we point to the hypotenuse, there's nothing labeled on the hypotenuse, so we don't need to worry about that. The 53 touches the x, so the x is the adjacent. It does not touch the 17, so 17 is the opposite. So opposite and adjacent is tangent. So tangent of the angle, 53, is equal to the opposite, 17, over the adjacent, x. So we're dividing again, so we need to switch them. X is equal to 17 over the tangent of 53. So 12.8. Now, as far as checking this one, if you think about The hypotenuse is the longest side, and then the other two sides, the smallest angle will have the smallest side across from it. So if we've got 53 degrees right there, that leaves us with 37 degrees for the other angle. So that means that the side X should be shorter than the side across from the 53, and it is. Okay, let's do that last one. 26, so 10 is our adjacent, X is our opposite, so tangent of 26 degrees is equal to the opposite X over the adjacent 10. Here's where we multiply, so 10 tangent 26, 4.9. And that makes sense because 26 is definitely smaller than that other angle, so it should be the smaller side.